in this experiment we determine that is parallel combination of resistance. When two resistors are connected in parallel, what is the resistance combination? We will determine using this setup. Okay. So look at this. When two resistors are connected in parallel, what is the equivalent resistance? Equivalent resistance is 1 by R equivalent is equals to your 1 by R1 plus 1 by R2. If I simplify it, it will be R equivalent is equals to R1 into R2 by R1 plus R2. I think it is well known to all. Okay. So next thing, we will demonstrate this thing using this circuit diagram. I will make this circuit. I have made this circuit diagram. Okay. I will do the circuit according to this circuit diagram. So look at this. From this terminal we will go. So positive terminal, from positive port, one key is there. Okay. One key is there. After that, it is connected with the combination of resistance. So this combination of resistance, both are connected in parallel. So look at this. So this is one resistance, this is another resistance. So resistance actually inside this box there are resistance from this port to this port. So inside, if we open this lid, so you can see the resistance are connected in this thing. So now this combination, they are connected in parallel. So parallel means one is this resistance is there, another is this resistance, and this port I have connected, these two ports, and these two ports I have connected. That means they are connected in parallel. Okay. So we are there. That is from key. We connect one port to the resistance combination. So this is the port connected with resistance combination, and from this another thing, it is connected with the ammeter. This is your ammeter. Okay. So we are using some kind of milliammeter. Okay. And another port of this milliammeter, you can see another port of milliammeter is connected with the rheostat, and this rheostat, the end point of this rheostat is connected to the negative terminals. Okay, so according to this diagram, I have made the circuit, and we need to determine the potential difference. That's why we have to connect some kind of voltmeter. So look at this. So voltmeter is connected. One port is connected with the resistance combination. So this is your resistance combination. So one port is connected to here, another port is connected to the other port of this resistance combination. So this is the thing. Okay. So my circuit diagram is complete. Now what I will do, I will find out what is the potential difference across this. Okay, and what is the current flowing throughout this circuit. Okay, and when I get the potential difference and this current, I will use Ohm's law. All of you know Ohm's law. This V is equals to IR. From there, I will determine what is the resistance. Okay. So let's start. So look at this. So let's fix for some value. This is actually not the potential. This is the power supply. Okay. So this is the power supply. This is the potential difference across this resistance combination. Across this resistance combination, we have used some kind of voltmeter. So this is actually your voltmeter reading. Okay. So your voltmeter shows it is your 0.5. Okay. And this milliammeter shows that it is your 100. It is your almost 160. Okay. So your ammeter reading is 160. Okay, and voltmeter reading is your voltmeter reading is that is 0.5. Okay, so we will use some kind of, that is V is equals to IR, or R is equals to V by I. So V is your 0.5 volt and I is 160 milliampere. Okay, so look at this. This is voltage. This is in SI and this is in milliampere. So we have to convert this thing in order to get. Okay, so we have to convert this in same unit. So we will convert milliampere to ampere. Okay, so it is your 0.5 by 160 into 10 to the power minus 3 ampere. So this is your resistance. Okay, whatever the resistance we are getting this that is combination of this parallel. Okay, so this is your experimental value. Okay, so we will fix for another value. Let's fix another value. Okay, so let's fix for another thing. Let's say this value. Okay, so for this value, this is your voltmeter reading. This voltmeter reading is 0.6. Okay, and your milliampere reading is it is 170. Okay, so we will make a table. Okay, I have already made. We'll make a table, serial number, voltmeter reading, we will note voltmeter reading, we will note again the ammeter reading, and we will use that is Ohm's law to determine what is the experimental value of this resistance combination. Okay, so I have made 5 times for different value of this potential difference, and I got this resistance value using this Ohm's law. Okay, so after that I got this thing. I have taken the mean of this thing. This is the mean value of this resistance value. Okay, so look at this, it is your 3.7, and I have used this resistance. One is 10 ohm, another is 5 ohm. Okay, so theoretically we can determine what is the theoretical value of this resistance. So theoretical value using this formula, that is 5 into 10 by 5 plus 10. So theoretical value it is 3.33. Okay, and my experimental value is 3.724. That means we are very close to this experimental value. Okay, so in order to determine how close we are, okay, so that's why I have taken one, that is percentage error. So percentage error, that is theoretical value minus experimental value by theoretical value into 100%. So my experiment suggests that it is almost, my result is 12% close to theoretical value, and all of you know that is in experiment it is almost 20% error is acceptable. So according to this, my experiment is quite fruitful, and from this experiment we determine what is the equivalent resistance for a resistance. Those are connected in parallel. Okay. So in another experiment I have already demonstrated what is the how to determine the series combination resistance. That is resistance connected and series. What are the resistance value? Okay. So this is all about this your experimental determination of parallel combination of resistance. Okay. So that's all.